So I would like to introduce you Dr. Antonio Balderama. He's an associate professor of instruction in civil engineering at the University of Texas at Arlington. He earned his PhD in structural engineering from the University of Florida. His expertise centers on the characterization of extreme loading, like seismic, wind, impact, and explosions, structural response to natural hazards and industrial hazards, and the codification of structural loads. Today, Dr. Balderama will present his research on Hurricane Otis. With that said, I'm going to turn it over to Dr. Balderama so he can share his insights on the post-disaster assessment of Hurricane Otis. In this talk, he will walk us through the methodologies used to evaluate structural damage, highlight the critical data collected in the aftermath of the disaster, and discuss how these findings can inform the construction of more resilient infrastructure. Please join me in welcoming Dr. Antonio Balderama.
Great. So now that we can get back to our screen and that you can confirm that we can see it, let's get on with this presentation. So we're going to talk about the Hurricane Otis post-disaster assessment. My name is Antonio, and I'm very happy to be here. And this is a very brief agenda for the presentation. So first, we're going to talk about an overview of Hurricane Otis. Then we're going to take the approach of a structural designer working in Acapulco so that we can look at the jurisdiction design aspects, the hazards, and anticipate what could have happened. And this allows us to establish questions or hypotheses that can inform the FAST strategy. Then we'll look at the reconnaissance survey strategy, look at the areas surveyed, data collection methodology, a couple of the key observations, and then we're going to go over logistic challenges that could have improved our disaster experience on site and that weren't considered. And finally, lessons from Hurricane Otis that will allow us to address in the future and produce or contribute towards a more resilient community. So on the left side, you have GOES satellite imagery with a very clear structure of the eye. And on the right side, we have the trajectory. This hurricane category 5 went right through Acapulco. And it was subjected to a very rapid intensification from category 1 through 5 in 18 hours. A couple of the other key statistics that we have is that the estimated wind speed was over 160 miles per hour at landfall, and it became the strongest landfalling Pacific hurricane on record. And it obliterated commercial establishments. It destroyed building envelopes of high-rise buildings, and the estimated damage at the time of publication of the tropical cyclone report was $12 to $16 billion. So now we look at the Acapulco jurisdiction aspects that I was thinking about when planning the disaster with Steer leadership. I was sitting in my office and thinking what could have gone wrong. So we have on the left side the Comisión Federal de Electricidad. It says electricity, but it's actually the design manual. It's the American Society of Civil Engineering minimum design loads for Mexico, except that the Federal Electric Commission is the one that publishes it. So we have the 2015 earthquake design criteria and the 2020 wind design criteria. This is a region that's heavily subjected to high accelerations of the ground and high winds. This is unique. So from a previous bid that I had designed in Playa Diamante, I already had an idea that the accelerations that the ground would be subjected to were higher than those in California. And from that same bid, I had 141 and 164 kilometers per hour as a 3-second gust basic wind speed. Now, traditionally in this place, in this site, buildings, low-rise buildings and mid-rise buildings were governed by seismic loads, and the performance criteria governed the detailing. Most low-rise buildings were governed like this. In fact, the ground acceleration was so high that even those industrial steel structures with wind loads exceeding the earthquake loads would still develop and require ductility for earthquake descents. So the other concept that we had here is that in Acapulco, most of the high-rise buildings were outfitted with seismic dampers. And that's a key issue that we have to keep in mind. So this is the design criteria, and 330 kilometers per hour was the 3-second gust at 5-meter height that was measured in a dock in Acapulco over open water. So never mind the differences, open water versus open terrain. We've got 330 kilometers per hour, 200 miles per hour. So this considerations before the survey allow us to plan. And I went back and thought about the criteria embedded in the wind loading prescriptions: wind climate, influence of terrain, aerodynamic effects, dynamic effects, and criteria for safety and reliability, and thought, where could we have gone wrong? The codes in this place were written by engineers who were working in Western Ontario at the time of Alan Davenport. So pretty much very similar to ASCE 7. So we've got the simulations and reliability criteria over here. We've got the aerodynamic effects of the neighboring buildings and the building itself, and the dynamic effects. And we've got over here the potentially dynamic effects on the cladding elements. You've got the first floor, second floor, and fluctuations of the first and second floor, and the external pressures acting on those. So with those considerations, we set out and planned the strategy. A couple of limitations that we had were, first, security concerns. This is Acapulco, the main Acapulco Bay. This is Playa Diamante, and this was the no-go zone. Okay, a heavily damaged area, but it was the no-go zone because of security concerns. This is the Del Marquez Bay, a very small cove protected. So this wasn't included in the scope either. And the CFE recommendations were stay near the beach, tourist area, and by all means avoid going inland or towards the mountains. So we had to stay in this region and in this region. The other issue that we had from the PVR damage photos, and we already had questions to define the strategy. So we had no access to buildings, and we knew there were systematic failures to building envelopes. So our strategy was defined based on that, and we targeted building envelopes, roofs, for as many high-rise buildings as we could. And along the way, we would capture any data for low-rise and mid-rise buildings so that we could have a framework for comparisons. We would survey from the beach and survey from the street, which was kind of complicated. Somebody running around the beach and somebody running around the street at the same time. So we defined 8 neighborhoods, and we grouped the building surveyed into 20 clusters, okay? These clusters allowed us to compare or group the types of damage that we found. Data collection methodology. We were using drones, unmanned aerial vehicles, and the first use of the drone was fly high, survey the area, and it wasn't large geographic areas. It was an area consisting of a group of 8 or 10 buildings, and then we would zoom in and do panoramas wrapping up vertically along the building. And the backup or the complementary mode of data collection was via our cell phones, okay? This area was subjected to a no-fly zone. So the drone was not allowed. Key observations. So something very important here is the type of market that we were dealing with. This is a high-end, high luxurious architectural market sector with ambitious views, with ambitious spans. And the architectural projects would combine the use of veneer walls, curtain walls, infill walls as their cladding systems in a single building. Most buildings used those 2 or 3 types of systems. Lattice metallic panels, louvers, and cement boards were also implemented because these buildings needed ventilated facades or enclosures for the utilities shafts. And when we look at the damage, the hurricane didn't care. Regardless of the element type, all of these systems were systematically damaged. You'd combine many types of construction methods in a single building, but they were all obliterated.
Dr. Balderama, you also have about 2 minutes left.
Good, thank you. Our key observations from our low-rise commercial buildings, car dealerships, wholesale stores, distribution centers, lightweight industrial and non-industrial steel buildings subjected heavy damage at the main wind force resisting system, and surprisingly at the cladding for new buildings. New buildings were supposed to be up to code, subjected to very stringent regulations, and they were also subjected to those damage. Logistics challenges, no-fly zones, Army, airport, Navy facilities, very complicated. The birds of prey, they would target the drone, and that was annoying because we had to make sure that the birds stopped following the drone. Glare, the drone operator would be looking at the screen, but I am directing the drone operator and I cannot see the screen. Limited access to the beach, signal interference and limited access points, and traffic hazards in the main Acapulco Bay. So our lessons from this, at this point, we cannot identify what happened. We didn't have instrumented buildings. We couldn't access the buildings, but we can identify knowledge gaps for the wind engineering to the community to start investigating and solve those within the wind to damage chain. Some of these knowledge gaps, with the assumption that the buildings were built up to code, are the effects of recent extreme weather patterns on hurricane risk. We've been having observations of rapid intensification that need to be incorporated in the models. Urban canopies and flow within those urban structures. The dynamic response of the main wind force resisting system and the components and cladding of the building against wind. And retrofit and wind design criteria for components and cladding that's compatible with the performance of the lateral force resisting system. And finally, risk consistency evaluations in these types of sites like Acapulco, Charleston, San Diego, where there's not really a clear governing lateral load hazards. It could be earthquake or it could be wind, depending on the type of structure and the height. So at this point, risk consistency is an important component. And finally, acknowledgement is this disaster assessment was made possible because NSF and STEER supported it, and their leadership were always following through with every step of the process. So we can have a couple of questions.
Yeah, we have time for round 1, and I've also left your email in chat. So if anyone has a burning question, feel free to ask. Can you talk a little bit more about, you had mentioned there were some, getting the ideal data generally in the natural hazard and disaster field is really tough. So if you were to supplement with more data sets in the future, what would you like to use?
If I were to supplement with more data sets in this specific site, I would target the data recorded by the Mexican National Weather Service and the Mexican Water Commission, which also controls the Weather Service. They have plenty of weather stations in Acapulco, about 4 or 5. And that data is extremely valuable to understand the wind direction and how it affected the building. So to me, that's something that would be complementing this project and perhaps helping potential computational fluid dynamics, initialize computational fluid dynamics simulations or wind tunnel studies.
And is that data usually free, or do you have to request it and then it's up to the government?
The data is free. The
Okay.
government needs to give it to anyone who requests it. The problem is bureaucracy.
Yes, yes.
It's many channels to get through the data, and in one of the cases, energy was lost, power.
Yeah, but thank you so much for your presentation today, and you're welcome to stay on for the next presentation as well. I'm going to pass it on to Uriah. Also, can I get the screen back?
Let me try.
Thank you.
I think I got it.
Yes, thank you so much again. And Puriya is going to introduce our next speaker.
I think Mohammed's fine with the introduction.
Yes.
Yeah.
Okay, can you hear me now?
Yeah.
Yes, Mohammed,
Yeah.
go for
Yeah.
it.
Yay.
Yes, thank you so much. Thank you, Dr. Balderama, and I'm very glad that you accepted our invitation. Our next speaker is Dr. Brad Wham. He's an assistant research professor at the University of Colorado Boulder, where he serves as a managing director of geotechnical engineering and geomatics. He earned his PhD in geotechnical engineering from Cornell University. Dr. Wham's research focuses on buried infrastructures, resilience, earthquake engineering, and hazard mitigation. He also do research on the impact of wildfires. With that said, I'm going to turn it over to Dr. Wham so he can talk about his work on wildfire, specifically his work on Mashall Colorado wildfire. Yeah, Dr. Wham.
Thanks. It's great to be here today. Can you hear me okay?
Yes.
Yes.
Great. You should be able to see my screen in just a second. I appreciate the opportunity to talk a little bit on the Mashall fire. I think when we set this up, we did not have a good portion of Los Angeles burning, so it's pretty timely. And so I tried to update a couple of things to help us put this fire in perspective and some of the reconnaissance work that we hope that might be following up as we move forward with that. I'll talk about the Mashall fire, which impacted Colorado, but I wanted to give a quick background on myself. I do a lot of earthquake reconnaissance in Japan, New Zealand, and recently in Turkey. And my research typically focuses on buried infrastructure, including water distribution systems and other types of lifelines. As Mohammed kindly pointed out, I'm the managing director of the Center for Infrastructure, Energy, and Space Testing, where we do centrifuge modeling, full-scale testing on different infrastructure systems, and a number of other things. If you ever by CU Boulder, you should come check us out. We have some pretty cool facilities and some fun stuff going on. I thought I had 30 minutes, but I think I only have 15, so I will move very quickly through a couple of things, and including the Mashall fire overview, some of our field reconnaissance, and then I have a couple of topics there that I won't talk on, but I wanted to put there because I'll share these slides, and if people had some questions to follow up, we could talk about it. I'll jump right into the Mashall fire, which is December 30th, 2021. It was the most destructive in terms of money lost fire in Colorado history, over $1 billion in damages and 60,000 acres burned. Similar to the LA fires, heavy spring rains, bone dry summer and fall. Colorado used to get some snow. We had no snow up all the way through December. And then we had this 70-mile-an-hour sustained winds and 100-mile-an-hour gusts that just moved a grass fire very, very quickly through a region that then eventually became interacting with homes and took a number of structures. Just to put it in perspective, I added this down below. This is as of an hour ago, where the LA fires are, the Palisades, Eaton, and Otto. The Palisades, for instance, is about 4 times larger in acreage than the Mashall fire was, and the Eaton is about twice the size. So just to put those in perspective, on sort of what LA is dealing with, which is really challenging. And for anyone who's local there, has family or friends or colleagues there, I wish them all the best, and we'll do our best through this organization and others to support them as much as we can moving forward. A couple of information on sort of the area here, but I'll keep rolling through. Just another slide for perspective. In Colorado, we have a number of fires that have occurred historically in the mountain areas, which is where we typically think of these fires. Marshall Fire is the first one in sort of recorded history, if you will, or recent history that's occurred sort of in the urban area or residential area that's really has started down in sort of the plateaus here as opposed to in the mountains. This is a satellite image overview of the fire starting in the west, moving forward. And so as it pertains to reconnaissance work, satellite imagery is absolutely so important to these events. This one was taken by Maxar at 2 p.m. The fire started at 11 a.m. So this is during the fire, showing where it had progressed at that time. And I have studied this image for countless hours, trying to see what was going on at different times. And so working with, there's a lot of different European Space Agency, a lot of different groups out there that are taking imagery at different times. And I encourage you very strongly, while you're doing reconnaissance from the chair, or you're preparing to get out into the field, contacting these folks. They're very open to providing information when there's natural hazards. They can help. And I just want to point out that Maxar provided this image, and I'm very thankful for them. And I would encourage you to reach out to these folks, because they're willing to provide information when it really helps the public like this. This is an overview very quickly of some of the damaged areas. Again, the fire started in the west. Red are destroyed structures. The green are damaged structures. It moved essentially across this open space, a lot of grassland area, and then into the town of Louisville and also Superior, where a number of structures were compromised. This is a little bit better view of that satellite image. And I'll just point out that this is where I'm calling in from today in Louisville, where my home is. This is a picture of what it looked like when I was evacuating. And then the very next day, getting in there before the snow started falling to try to get some preliminary reconnaissance on the lay of the land and kind of understand what the impacts were and what types of resources we might need to try to understand this thing a little bit better. We had some issues, and I'll use this as an example. This is a structure, and you can see the water service line. I do a lot of work in water lines, and so this is a water line where the home is completely destroyed. It's leaking into the foundation. The water utilities talk about death by 1,000 cuts. And this is one of the reasons why we lose water during firefighting efforts. Obviously, there's this huge demand in the firefighters pushing water through the hydrants, but we also have any damaged structures where if we don't turn the water off immediately, we have a large demand even from the households that exist. And so that's a really important thing that we learned in the Marshall Fire, and some information we're getting to the folks in LA here, that we've got to cut off these lines and stop the bleeding, if you will. Through some of other projects that we've worked on in looking at water quality following fires, we were in and helping the local water utilities plan how to clear various contaminants out of their systems, VOCs, SVOCs, and other types of things that happen during fires that we've recognized more recently. And we have a couple of active research projects in that area that I'll keep moving through. I'll keep moving through with a really brief background. And the reason why reconnaissance is so important in the Paradise, California, the schools weren't able to open. Although they didn't burn, they didn't have clean water. They were getting hits of the types of contaminants. And so my great colleague Erica Fisher out of Oregon State and I have been working on a project looking at how this contamination gets into the system. And because of that sort of background and that research that she had initially done for the reconnaissance work she'd done for the Paradise Fire, we had a set of information that we could directly help and support the utilities for the Marshall Fire, and we're continuing to share some of those lessons learned with LA today. Once we got in and got some of the initial things done, we moved forward with a field reconnaissance team. We ran this through GEAR, Geotechnical Earthquake Geotechnical Extreme Event Reconnaissance Team, similar to STEER. And this is the first time we responded to a fire through gear, which was great. We had folks from Oregon State, a number from CU Boulder, where I'm at, including Abby Lyle, Shude Dashti, Amy Jabernack-Will, and Andy Welton out of Purdue University. We used the RAPID team out of University of Washington. They were absolutely fantastic in helping us gather so much of this data that we're going to show you here. They just sent out, I think this morning, a workshop where you can go and learn how to use the equipment and things like that. And I would strongly suggest students that are able, they have travel grants to go. I'd strongly suggest anyone interested in reconnaissance to do that. I went through that program maybe 8 years ago, maybe the first time they offered it. And it was really, really helpful in knowing the types of things they do, how they operate, and how to get things in and really produce as much information as quickly as possible. The overview of the GEAR mission, we're looking at characterizing homes, performance of slopes and retaining walls, behavior of the water utilities, and then changes in policy. I won't be able to get into all this, but we ended up doing 3 individual in-field data collection missions through this process. And some of that was because of the snow cover here in Colorado that did finally come and hindered some of our ability to capture images. Through those 3 different deployments, we use a number of different types of UAVs and LiDAR systems and a number of other things. We use the flight that you're seeing in the bottom left is the first time they flew Trinity, which is a fixed wing aircraft that can cover a tremendous amount of area and gather a tremendous number of photos to develop different types of data. We use quadcopters in areas where we need to be a little bit lower. And then we use LiDAR scans and structures from motion to develop 3D models in a number of different ways. This is an example of our planning, which is really fun when you get into this and like, where do you want to, what areas do you want to capture? How do you build these polygons to actually give to the flight teams to decide where to go? And so that's where some of the satellite imagery came in. That's where some of the on the ground field reconnaissance looking around. And so these are example of kind of our back of the envelope, you know, let's do this area, let's do this area, let's grab these spaces, and these are where we want to target. Using Google Maps, right, which is a great tool, and I encourage folks to use. Another one of the challenges, as Juan pointed out, is airports and where you can fly and not. And so the red lines here are indicating areas where we had to fly below a certain level because of a nearby airport. And so that's why having different pieces of different types of flight capabilities is really important in being able to capture different areas. This is an example of our 2D ortho mosaic map that we gathered from mostly fixed wing aircraft, but some of the other ones. The detail of this map is really just unbelievable. This is an example of one of the pictures where we can measure, we can see the cracks in the concrete, right, in the asphalt and different damages. We can really get in and capture before debris removal, before everything changes, what the state of things were at different periods following it. I will share these slides. There are links. This stuff is all available. If I had time, I would throw up and really zoom into some of these maps, but I'll be happy to share some of that stuff. This is one of the structures from motions models where we're looking at sort of a 3D view and be able to get some of the elevation that the orthomosaic can't quite capture. And this is an example of how some of that 3D modeling works. This is approximately I think it was 18-meter tall retaining structure, 3-tier retaining structure. There was wood railroad ties that were holding it back, and many of those burned out. And so as an example of how this was used, here is a structure that was obviously destroyed and another one right on top of this hill. The city had a lot of questions about what do we do with this site? Do we tear down the retaining wall? Is it okay? How do we do our slope stability? So we were able to give this to some of the engineers. They would do some slope stability analysis on this and use it to help inform the homeowners on how to kind of move forward with rebuilding, whether or not these lots were compromised or not, and how the retaining structure needed to be built and come back. All this stuff you can take pretty detailed measurements with and is really quite valuable. So just an example of how some of this data is used. Another really quick example is some of the ground surveys we did. So looking at homes that survived, homes that were lost, their proximity to one another, and some of the features associated with those various homes in those various neighborhoods. It's one thing to go out. We did a number of ground surveys where we were taking in data, but there's a lot of data to take in just one area. And so we were able to use this, compare it to our other other data sets that we developed from the UAV flights and things like that, compare them back and forth and be able to extrapolate what we did with our ground surveys across the entire area, which is something I hope that will be useful for some of our friends in California as things move forward. An example of some of the WUI code recommendations and some of the things we're looking at. I won't get into too much detail here because of time, but some specific things is closeness of space houses, the intensity of the fire in different areas, looking at vents and the ability for embers to get into different areas, into the homes, which is extremely important. Fences touching homes is really important too. That's how it travels from house to house sometimes, depending on the wind and how it's operating, and then proximity to open space. And so this is an example of where we have a lot of open space in Colorado where the fire just really moved through these grasses, these grasslands and came into homes. And then also interviewing and working with the firefighters to understand how they strategize fighting this thing, which were just some unbelievable stories and things as we work through this process. So some kind of ongoing ways that we use this data is we shared it with the local municipalities, which aided in their recovery and decision making. We had a number of follow-on grants, NSF Rapids looking at housing policies, Water Research Foundation grants looking at the water utility response, where this data is continuing to be used. I was on a call with a lawyer yesterday asking questions about fire initiation and where it happened and how that happened, and the details of our flights and things provide valuable information, kind of figuring some of that out. Water contamination studies. We worked with the open space folks on how planning moving forward and where they want to have fire barriers based on some of the mapping and things. We did some pavement assessments, helped with rebuilding efforts. The data was used by a FEMA MAT team that we helped advise as they came through, and social science surveys, and a whole bunch of things that I know nothing about because this is publicly available data. People are using it, and every now and then we'll get another citation. We'll say, hey, look, our data was helpful. We didn't even know that they would use it for that. So really some great stories about all the work that went into capturing some of this stuff. I want to acknowledge the municipalities that we worked with throughout the process. Our students, we had a number of graduate students and undergraduate students from CU Boulder and OSU and others that were out there in the field. This is a picture of some of us. This was during COVID, of course, so we all had our masks on and participating in some of this work. The NHERI Rapid Center was huge in getting a lot of this work done. National Science Foundation and Water Research Foundation for funding. And my email's there if there's any questions or follow-ups you guys might have. And I have some references and resources here. A number of papers have come out since on a number of different kind of pieces of this and some of the follow-on studies. So I'm a little over, so hopefully that wasn't too far over. Maybe there's a time for a question or two. Thanks.
Thank you, Dr. Wham. Is there any questions?
I guess I have a question. No, go ahead. Whoever the other person was.
Yeah, hi, I'm Iman. I have one question. As you were talking about the water distribution methods and surveying that, I had one question pertaining to if there were any technologies used, such as ground penetrating radar or something similar to that, that was used into surveying when you're detecting any maybe buried valves or just systems in general, especially after the post-disaster scenario, if there was any debris around that. Was there any way or specific methods you used to find those specific valves?
Iman, that's a really great question. Thank you so much for it. There were significant challenges that the water utilities faced when they were trying to locate the shutoff valves for all of these individual properties. One of the things that they used immediately after the fire was one of the utilities had iPads with their system marked out on it. So they had the location of the valves and it was GPS. And that was really, really valuable for them because one of the utility members mentioned they were driving through neighborhoods that they'd driven through hundreds of times before and they didn't recognize anything. They didn't know where they were, on a street that they knew. All the different things were gone. And so that was a really valuable piece that has come out of this that says having the GPS, having a map of your utility with these things marked out and having it GPS capable is really important. You asked specifically about ground penetrating radar. We didn't do too much work with that from our reconnaissance. We were trying to capture sort of the global and everything. Another big challenge is during debris removal, where they're digging up these lots and they're getting rid of the debris. They're hitting all of the service lines and the different types of pipes all the time. And the folks doing the markouts did come through and did their best to mark out, and they use some of those types of technologies themselves. But there was definitely some challenges with that and some stuff that got ripped out of the ground that was, unfortunate. Some of it needed to be removed and some of it didn't. So I can see a lot of opportunities for those types of technologies coming in and helping folks as they're trying to figure out where things are and as they're trying to rebuild and some of those challenges as they move forward.
Thank you.
Thank you.
Arman, do you want to ask a question?
I can't. I just always have a backup question prepared. But when the community was rebuilding, did you do any work with people who knew more about insurance? Did insurance come through and actually pay off these houses? Yeah. Do you know what happened?
Yes. So you ask a very detailed question. I don't know if we have another 2 hours here. It's a really big challenge with insurance. We're seeing that in California here. Many people in Colorado were underinsured. And so the cost of rebuilding, especially when the costs go up because there's so many people that want to rebuild at the same time, is a really significant challenge. And so many people fell short in what the insurance company was willing to give them back for their house and to be able to rebuild to the same level. It's a bigger question with these high wind events being more common, the frequency going up. I'm not an expert in the area, but there are some things we need to do at the state, federal, whatever levels to help make sure that we can have insurance for our homes and be able to reasonably afford it. So I know there were a lot of challenges. We have a paper, one of the ones that referenced talks about some of the rebuilding efforts and some of those challenges, Ellenly et al. And I would encourage you to take a look at that one. And I think they talk a little bit more about it in detail if you're interested in more information on it.
Yeah, thank you.
Thank you so much, Dr. Wham. I want to remind everyone that we have, I put a Google Sheet in the chat and sign up for the RSR meetings. And I want to invite everyone to stay connected. This was our first meeting and for Reconnaissance actually. And please feel free to contact us if you have any suggestions. If you think that we need to do something differently, and thank you all. Thank you, everyone.